Good morning, students. Yesterday we learnt about the structure of the earth. We came across several terms like the soil, the cyma, crust, lithosphere, mantle, and so on. Today we will learn in detail about the interior of the earth. So when we talk about the interior of the earth, we can compare it with that of an egg. Now, how can we do that? Since the egg has got three distinct layers with different density, the earth also has got three distinct layers with different density. The core, which is the heaviest and the densest, is found at the center, just like that of an egg yolk. The mantle, which is semi-solid, is found around the core, is similar to that of the albumin, which is found around the yolk. While the crust, which is the outermost layer of the earth, is the thinnest, just like that of an eggshell, which is thinnest and the most fragile. Now moving on to the next part of the topic, that is the interior of the earth. We must understand that the earth's interior is made up of concentric layers, which are made up of minerals which have solidified with time and have been laid down in such a way that the heaviest is at the center, forming the core, and the lightest is found on the top, forming the crust. So, the layers of the earth consists of the crust, the mantle, and the core. Right now we will learn about the crust, which is known as the lithosphere. Now, lithos means rocks or stones in Latin, and sphere means a circular body. The crust is very thin, and on an average, the thickness is of about 60 kilometers approximately, and covers about 1% of the earth. In fact, it covers about less than 1% of the earth. This crust consists of two layers, the soil and the cyma. The soil is made up of silica and aluminium, which makes up the continents, and it is 25 kilometers in thickness. The continents are composed of lighter rock materials made up of silicon and aluminium. So the soil is thick over the continents and very thin or absent on the ocean floor, especially the Pacific Ocean floor. The average density of the soil is 2.7 gram per cubic centimeter. The cyma is below the cyle and it is made up of basaltic plates which consists of silica and magnesium. The average thickness of the cyma is 35 kilometers. Cyma forms the oceanic crust and it is mainly found under the ocean, composed of denser or heavier rock material. So students, cyle consists of silica and aluminium, while cyma consists of silica and magnesium. A very important term which you need to know is the Moho discontinuity. Now this Moho discontinuity is the boundary between the crust and the mantle. It is 5 kilometers thick in the mid-ocean and 75 kilometers thick at the continental shelf. Apart from the crust, next we need to learn about the mantle. The mantle is between the core and the crust. The material with which the mantle is made up of is magnesium and iron. We also call it FEMA. The mean density of the mantle is about 4.5 gram per cubic centimeter. It varies with 3 gram per cubic centimeter on top and 5.5 gram per cubic centimeter at the bottom. That means the mantle is having lighter material on the top, while as we move towards the center or below, the mantle becomes heavier. The average thickness of the mantle is 2,800 kilometers. Mantle is also subdivided into two distinct layers, that is the upper mantle and the lower mantle. The upper mantle is known as the asthenosphere, while the lower mantle is known as the mesosphere. This layer has been located through the decrease in velocity of earthquake waves, so it is referred to as the lower earthquake velocity zone. This is because when an earthquake occurs, different waves begin to travel from the crust towards the center of the earth. And because of the bending of the P waves, so this area is not able to be affected, mainly because of the bending or refraction of the P waves of the earthquake. The lower mantle behaves like a solid due to extreme pressure which is exerted from the top. The temperature in the mantle is very high. It is about 850 degrees centigrade in the upper region and 2208 degree in the lower region. There is a zone of discontinuity in the density between mantle and core, which is known as the Gutenberg discontinuity. So students, please remember, wherever the density of the minerals in the interior begins to change, we have a discontinuity. We have the Moho discontinuity between the crust and the mantle. We have the Gutenberg discontinuity between the mantle and the core. Now the central layer of the earth is known as the core. This dense layer is also known as the barosphere. The core of the earth has a radius of 3,500 kilometers. The core is made up of very dense materials, mainly nickel and iron. That is why it is also known as the Nephi. The core is subdivided into two zones, the inner core and the outer core. The outer core behaves like liquid and does not let the earthquake waves to pass through it. The inner core behaves like a solid layer due to extreme pressure and temperature over here. The core has dense material of nickel and iron, and the density is 13 gram per cubic centimeter to nearly 15 gram per cubic centimeter. The temperature over here is the highest, that is nearly 5,000 degrees centigrade. The iron present in this core loses its magnetic properties at such a high temperature. The scientists think that due to the rapid rotation of the earth, the electric currents originate in the liquid core which are responsible for the formation of the magnetic field around the earth, about which we will be studying in the later part of the lessons. So students, I hope I have made myself clear while explaining to you the core, the mantle and the crust. You are supposed to go through page number 36, 37 and 38. So that is what we have enough time for today. Thank you. Have a nice day.